Students, this is question number 1 from exercise 1.2. Prove that root 5 is an irrational. Okay, we have to prove that root 5 is an irrational number. Okay, let us assume that root 5 is a rational number. Okay, when we have assumed root 5 as a rational number, we can write root 5 as root 5 is equal to p by q. We can write root 5 is equal to p by q, where p and q are co-primes. P comma q are co-primes. Okay, q not equal to 0. Co-primes means P and Q have the only common factor 1. Okay, P and Q have the only common factor 1. Okay, now this problem is as easy as eating a cake. Okay, just you have to practice twice or thrice. If you practice twice or thrice, your pen will run as fast as do not expect. Okay, just I will apply square on both sides. Root 5 whole square is equal to p by q whole square. Okay, square and root get cancelled. So 5 is equal to p square by q square. Now simply I will take q square to the left hand side. I will write 5q square is equal to p square. Now I will send p 5 to the right hand side. I will get q square is equal to p square by 5. Here you can observe that 5 is dividing p square, then 5 divides p also. You can write 5 by p. Now p, you can write p as 5 into something. For example, 10 by 5. 10 by 5, take this is p and this is 5. Okay, you can write 10 as 5 into something, means 5 into 10. In the same way, you can write p as 5 into r. Okay, you can write p is equal to 5 into r. Means these are the products, these are the factors of p. Now take q square by q square is equal to p square by 5 as equation 1 and substitute p is equal to 5r in equation 1. Okay, write equation 1 first and I will rearrange. I will write p square by 5 is equal to q square. P square by 5 is equal to q square. Substitute p is equal to 5r. 5r whole square by 5 is equal to q square. 5r whole square is equal to 25r square. 25r square by 5 is equal to q square. Now cancel 25 and 5. 5 ones, 5 5s, 25. 5 ones, 5 5s, 25. I will get 5r square is equal to q square. Now write, send 5 to the right hand side. R square is equal to q square by 5. Here also you can find that 5 is dividing q square. Then 5 divides q also. 5 divides q also. You can write q by 5. Now observe the very important thing here. 5 is dividing p. 5 is dividing p and 5 is dividing q also. Means p and q have the common factor other than 1. In the beginning I told you that p and q have the common factor 1 only. But at the end we have found that p has the common factor, p and q have the common factor other than 1. So you can write it contradicts the fact that root 5 is an irrational. This contradiction has arisen because of our incorrect assumption. Incorrect assumption. Therefore, root 5 is an irrational. Hence, proved. Hello students, today we solve question number 2 from exercise 1.2 of first chapter real numbers. Prove that 3 plus 2 root 5 is irrational. We have to prove 3 plus 2 root 5 as irrational. Now we will use contradiction method to prove 3 plus 2 root 5 is irrational. Okay, let us solve the problem. Let us assume that 3 plus 2 root 5 is a rational number. Then we can write 3 plus 2 root 5 is equal to P by Q. 3 plus 2 root 5 is equal to P by Q. Where P and Q are co-primes and integers, Q not equal to 0. P comma Q are co-primes, Q not equal to 0. Okay, this question is very simple. Simply send 3 to the right hand side. 2 root 5 is equal to P by Q minus 3. You can write 3 by 1. 2 root 5 is equal to, find the LCM of Q and 1, we will get Q. Now cancel P by Q into Q. We will get P minus 3Q. 2 root 5 is equal to P minus 3Q by Q. Now I will send 2 to the right hand side. Root 5 is equal to P minus 3Q by Q. Otherwise P minus 3Q by 2Q. I will send to the right hand side. It goes under division 2Q. Observe the right hand side. We have got 3, 2, P and Q. These are all non-zero integers. If we substitute P and Q with some non-zero integers, we will get the whole term a rational number. Okay, we will get the whole term a rational number. Okay, we can write since 2 comma 3 comma P and Q are non-zero integers, we get P minus 3Q by 2Q a rational number. A rational number. Okay. Now, what do you observe here? Observe root 5. Root 5 we have written root 5 is equal to P minus 3Q by 2Q. According to the problem, root 5 is equal to P minus 3Q by 2Q. Okay, according to the problem, P minus root 5 equal to P minus 3Q by 2Q. But one thing we have to observe. Observe root 5. Observe root 5. What is under the square root? A non-perfect square number is present under the square root. Non-perfect square number is present under the square root. What are the non-perfect square numbers? Such as 2, 3, 5, 6, 7 and some other numbers. If you find these numbers under the square root, we can say that this is a irrational number. This is a irrational number. But we have found that we have found that a non-perfect square number is under the square root. Therefore, root 3 not equal to p minus 3q by 2q. Okay? This contradicts the fact that root 5 is an irrational number. The contradiction has arisen because our incorrect assumption, you can write. The contradiction has arisen because of our incorrect assumption. Therefore, root 5. Therefore, 3 plus 2 root 5 is an irrational. Hence, proved. Hello students, we solve question number 3 from exercise 1.2. There are total 3 bits. We will solve the first one. We have to prove that 1 by root 2 is an irrational number. Okay, we know that 1 by root 2 is an irrational number. Despite knowing, we have to prove that 1 by root 2 is an irrational number. So, we will use the contradiction method. Let us assume that 1 by root 2 is a rational number. Then we can write 1 by root 2 is equal to p by q, where p and q are integers, p comma q are integers and co-primes. Q not equal to 0. Okay, I will do the cross multiplication. 1 into q, p into root 2. Okay, p into root 2, p into root 2, p root 2 is equal to 1 into q, 1q. Okay, I will write q. Now I will send p to the right hand side. So we get root 2 is equal to q by p. Observe, q and p are non-zero integers. If we divide q by p, we will get a rational number. Okay, we will get a rational number. Since p and q are non-zero integers, if we divide q by p, we will get rational number. Integers, we get q by p, a rational number, and according to the problem, and also according to the problem, root 2 is equal to q by p. But we have to observe, what is root 2? A non-perfect square number is under the square root. Non-perfect square number is under the square root, then root 2 is an irrational. We know that root 2 is an irrational number. But a non-perfect square number such as 2, 3, 5, 7, 5, 6, 7 and so numbers and other numbers. But a non-perfect square number is under the square root. Therefore, root 2 is an irrational. Then root 2 cannot be equal to q by p. Root 2 cannot be equal to q by p. Okay, have you got this? This contradicts the fact that root 2 is an irrational. This contradiction has arisen because of our incorrect assumption. Therefore, 1 by root 2 is an irrational. Hence, proved. Well, we solve second bit. 7 root 5. We have to prove 7 root 5 is an irrational number. Okay? We will use the contradiction method. Let us assume that 7 root 5 is a rational number. Then we can write 7 root 5 is equal to p by q. 7 root 5 is equal to 7 root 5 is equal to p by q, where p and q are co-primes and integers. P comma q are co-primes, q not equal to 0. Okay, simply I will send 7 to the right hand side. I can write root 5 is equal to p by q, p by 7q. Okay, p by 7q. Observe, root 5 is equal to p by 7q. What do you observe here at the right hand side? P, 7 and q. These are all integers. These are all non-zero integers. Okay, if we substitute p and q with some non-zero integers, we will get the whole term a rational number. So, since we can write, since 7p and q are non-zero integers, if we perform any operation such as multiplication, division, subtraction or addition, we will get p by 7q a rational number. Since 7p and q are non-zero integers, we get p by 7q a rational number. And according to the problem, root 5 is equal to p by 7q. But we have to observe here, observe the left hand side, there is root 5. There is non-perfect square value under the square root. If you find the non-perfect square value under the square root, we can say that this is an irrational number. Irrational number cannot be equal to rational number. This is rational number and this is irrational number. Is it possible? This is not possible. Okay? But we have found that a non-perfect square number is under the square root. Therefore, root 5 cannot be equal to p by 7q. This contradicts the fact that root 5 is an irrational. This contradiction has arisen because of our incorrect assumption. Therefore, 7 root 5 is an irrational. Hence, proved. Students, we solved third bit of question number 3. This is the last question and last bit of exercise 1.2. Let us solve 6 plus root 2 as irrational number. We will prove 6 plus root 2 as irrational number using contradiction method. Okay, let us assume that 6 plus root 2 is a rational number. Then we can write 6 plus root 2 is equal to p by q. 6 plus root 2 is equal to p by q, where p and q are integers, and co-primes. Q not equal to 0. Okay, simply send 6 to the right hand side. We will get root 2 is equal to p by q minus 6. You can write 6 by 1. Root 2 is equal to, now you write, find the LCM of q and 1. What is the LCM? Q. Now cancel p by q into q. Okay, multiply p by q into q. I will get p. Now 6 by 1 into q, 6q. Okay, root 2 is equal to p minus 6q by q. Okay, observe here. Here in the right hand side, we have 6, p and q. These are all integers. If we substitute p and q with some integers, we will get this whole part a rational number. Okay, we will get this whole part as a rational number. Since 6, p and q are non-zero integers, if you perform any operations, arithmetic operations such as addition, multiplication, subtraction or division, we will get p minus 6q by q a rational number. We get p minus 6q by q a rational number. According to the problem, root 2 is equal to P minus 6Q by Q. But after observing the left hand side part, we will come to know that root 2 is an irrational. Why? Why root 2 is an irrational? Because the non-perfect square value is under the square root. If you find the non-perfect square value under the square root, we will say that that number is an irrational number, such as 2, 3, 5, 6, 7 and some other numbers. We have found the non-perfect square number under the square root, then we can say that root 2 is an irrational and it cannot be equal to P minus 6Q by Q. So this is very impossible to be equal. We can write we have found a non-perfect square number under the square root. Therefore, root 2 cannot be equal to P minus 6Q by Q. This is not equal to P minus 6Q by Q. This contradicts the fact that root 2 is an irrational number. The contradiction has arisen because of our incorrect assumption. Therefore, 6 plus root 2 is an irrational, hence proved.